So we continue with radioactivity. Now we look at half-life. What is half-life? Half-life is simply the time taken for half of a present element to decay. So what it is this. If this is the element, the time it takes to go from the whole to half of the element. After that same time, well, half again will decay. After the next half-life, half again will decay. And so on, and so on, and so on. Right? So, how do we calculate or how do we work with this half-life? So, a half-life is how long it takes to go from the present amount to half of that. So, let's say we started off with a whole, right? One whole. So, on 0 half-lives, we have a whole, and the amount decayed is 0. Let's say 1 half-life went. After 1 half-life, what will happen? After 1 half-life, what you would observe is that half of what you have would have decayed. So, half would have decayed, so it means you're left with a half. That's okay? And next half-life, what would have happened? Well, half of the present amount decays. So after this, half of this will decay, half of this is a quarter. So how much would have decayed? If you're left with a quarter, then 3/4 would have decayed. That's okay? After the next half-life, what would have happened? Half of this, which is 1/8. So therefore, 7/8 remain. Let's do one more. And next half-life would have gone, then you would have 1/60. And this is standard. You could learn this, or you could learn the formula that will be at the end here. So let's say we have n half-lives now. What will be the fraction left? Right? So look at this. When it was 3 half-lives, we had an 8. When it was 1, it was a quarter. Well, that's a nice little formula. 1/2 to the power of n. So after n half-lives, let's say 4 half-lives, it will be 1/2 to the power of 4 left. Right? And the k will be 1 minus that. So if I have 1/8, 1 minus 1/8 is 7/8. And that's the way we work out half-life. For example, let's say we started off with 200 grams of something. 200 grams of some radioactive element. So, after 1 half-life, what will have happened? After 1 half-life, 100 grams will remain. Make sense? And next half-life, 50 grams will remain. After the next half-life, 25. Next half-life, 12.5, and so on and so on. Right? So every half-life, half of what is present is decayed. So let's give an example with half-life now. Let's say the half-life is something in 2 days. On the 0th day, you have 200. After 2 days, you have 100. After 4 days, which is the next half-life, you have 50. After 6 days, you have 25. After 8 days, you have 12.5. So every 2 days, you have half being decayed. And that's the concept behind half-life. If you look here, this is called a decay curve. It represents how a radioactive element will decay. So let's say we started off with 200. After 200, we started 200 grams. After 1 half-life, we will end up with 100 grams. So let's say this was days. So time in days. So after 1 day, 200 grams will go to 100 grams. After the next day, which will be 2 days, 100 will go to 50. Okay? And after 3 days, 50 will go to 25. And this will continue exponentially and until the atom basically disintegrates. But it's an exponential shaped curve, as you can see. Right? And this is the concept behind half-life. Half-life is the time taken to go from the present amount to half that. Okay? So this is basically how we find half-life.